Assalamu alaikum students. I hope you all are good. Today we are going to start our first chapter, that is sets. Let us start by revising some basic sets of numbers. The first one is set of natural numbers. Set of natural numbers is represented by a capital N and it includes all the counting numbers starting from 1. Next we have a set of whole numbers. The set of whole numbers is represented by a capital W and it includes 0 and all the counting numbers. The difference between the set of natural numbers and set of whole numbers is that the set of whole numbers contains 0 in it, while the set of natural numbers does not have 0 in it. Next we have the set of integers. Set of integers is represented by capital Z and it includes all positive numbers, all negative numbers and 0. Next we have a set of positive prime numbers. Prime numbers are the numbers which are not divisible by any other number except 1 or the number itself. So the set of positive prime numbers is represented by a capital P and it includes 2, 3, 5, 7, 11 and so on. Next we have the set of odd numbers. Set of odd numbers is represented by capital O and it includes all the numbers that are not divisible by 2. It means the set of odd numbers will have 1, 3, 5, 7, 9 and so on. Next we have set of even numbers. Set of even numbers is represented by a capital E and it includes all the numbers that are divisible by 2. It means the set of odd numbers is start from 0, then it has 2, 4, 6, 8 and so on. Next we have a set of rational numbers. Set of rational numbers is represented by a capital Q and it includes all the numbers that can be written in the form of P upon Q. P upon Q means in the form of fraction where P and Q belongs to Z and Q is not equals to 0. It means all the numbers that can be written in a fraction form will belong to the set of rational number. P is the numerator and Q is the denominator, and Q denominator must not be equals to 0. Let us take some examples. For example, if we have a number 5, will it belong to a set of rational number? Set of rational numbers says all the numbers that can be written in fraction form. Can we write 5 in a fraction form? Yes, we can write by putting 1 in the denominator. 5 can be written as 5 upon 1. It means 5 will belong to the set of rational number. One more example, if we have a number 2 upon 3. Is it in fraction form? Yes, it is in fraction form. It means the number 2 upon 3 will also belong to the set of rational numbers. Similarly, we can take 1 upon 5 or we can take any other fraction. If we have a number 2.5, will it belong to the set of rational number? Let us check. If we remove 0, if we remove decimal and put 1 in the denominator and put 0 in place of 5, now this 2.5 is written as 25 upon 10. It means 2.5 can be written in fraction form. It means 2.5 will belong to the set of rational numbers. One more example. Let us take square root 4. Is it a rational number or irrational number? Square root 4 is equals to 2, and 2 will belong to the set of rational number. It means square root 2 is a rational number. Next we have a set of irrational numbers. Set of irrational numbers is represented by q dash, and it includes all the numbers that cannot be written in the form of p upon q, where p and q belongs to integers and q is not equals to 0. The numbers that cannot be written in fraction form will belong to the set of irrational number. Let us take some examples. If we have a number 3.21467 and so on, it means a non-terminating decimal numbers. If we have a non-terminating decimal number, can we write it in a fraction form? Let's try. Remove the decimal, put 0 in the denominator. Now start putting the 0. A 0 in place of 2, a 0 in place of 1, a 0 in place of 4, a 0 in place of 6, a 0 in place of 7, and then infinite many zeros. It means we cannot write a non-terminating decimal as a fraction. It means a non-terminating decimal will belong to the set of irrational number. Take one more example. If we have a number square root 7, square root of 7 is equals to 2.6457 and so on. It means it is a non-terminating decimal number. Non-terminating decimal number, it means we cannot write it as fraction. So square root 7 will belong to the set of irrational numbers. Okay, the numbers which cannot be written in fraction form will belong to the set of irrational number, and the numbers which can be written in the fraction form will belong to the set of rational numbers. Next we have a set of real numbers. Set of real numbers is represented by capital R, and it includes all the rational numbers and all the irrational numbers. It means if we combine all rational numbers and irrational numbers, we will get a set of real numbers. Set of real numbers will include every number, all the negative numbers, all the positive numbers, all decimal numbers, all square roots, all cube roots. Every number will be included in the set of real numbers. Moving forward, what is a set? Set is a collection of well-defined and distinct objects. Set is a collection. Set is a collection of well-defined and distinct objects. Well-defined means that a rule can be stated which determines either an object is a member of a set or not. And distinct means that each object of the set is different from all other members of the set. It means a set cannot have two same elements. Let us take an example. A x such that x belongs to z positive. It means we are taking a set of positive integers such that x is less than 5 and the elements including in the set are less than 5. It means the set will have 1, 2, 3, 4 and 5. Here we can say that the rule is x belongs to positive integers and x is less than 5. That is the rule which determines its members, and we can see that each member is unique. There are no two similar elements. It means this is a set. For being a set, two conditions must be satisfied. The first one is well defined and the second one is distinct. Moving forward, we have types of sets. The first one is empty set. As the name indicates, a set with no element is called the empty set. If we are making a set and the set contains no element, will be the will be called empty set. For example, a set A, the set of the days of a week whose name starts with P. If we are making a set of days which starts with letter P, then we have no element in our set. It means A will be an empty set. Or number of elements in set A is equals to 0. There will be no element in set A. We can say that set A is an empty set. There are two symbols which we can use to represent empty set. The first one is empty curly bracket and the second one is slashed 0. Please make sure not to combine both the symbols. It is just curly brackets, empty curly brackets, or 0 with a slash. It is not something like this. A curly bracket inside a 0 and slashed. Okay, the symbol which we use for empty set are empty curly brackets or slashed 0. Do not combine the symbol, it is wrong. Okay, the next type of set we are going to study is singleton set. Again, the name indicates singleton set means a set with only one element. A set which has only one element is called a singleton set. Take an example, a set A, the set of the days of the week whose name starts with W. Now we are making a set of days whose name starts with W. We will have just one single element in our set, that is Wednesday. This set is called the singleton set. Number of element in set A is equals 1. Set which contains only one element will be called singleton set. Moving forward. Next we have finite set. Again, the name indicates a set with limited element. A set which has limited element is called the finite set. For example, we are making a set. Set F is a set of counting numbers less than 6. If we are taking counting numbers less than 6, then the set will have 1, 2, 3, 4 and 5. Number of element in set F is equals 5. Here we have countable elements. Here we have limited element. So the set F is called the finite set. Next we have infinite set. Again, the name indicates a set which has unlimited elements is called the infinite set. For example, we are making a set N which is a set of counting numbers, all counting numbers. Then it will include 1, 2, 3, 4, 5, 6 and so on, infinite many numbers. Then this will call infinite set. Okay, moving forward. Equal and equivalent sets. Equal sets are the sets that have the exact same elements. Two sets are called equal sets if they have the same exact element. Their order doesn't matter. It doesn't matter whether the arrangement of numbers or element is same or not, but the elements must be same. Take an example. Set E. Set E is the set of letters in the word earth. We are making a set which contains the letter in the word earth. So the set E will contain EARTH. Now take another set, set H. Set H is the set of letters in the word heart. Now the set H will have HEART. Now check both the sets, set E and set H. In set E we have EART. H-E-A-R-T-H. In set H we have H-E-A-R-T. Elements of both the sets are same. Exactly same elements are present in set E and set H, but their arrangement is not exactly the same. It may be same or it may not be same. So we can say the set E and set H are equal sets. The sets that have exactly same elements are called equal sets. One more example. Set A contains S, Y, M, B, O, L, 6 English alphabets, and set B have B, O, M, Y, S, L. Again, the elements of both the sets are same, exactly same. So the set A and set B are called equal sets. You may take different examples. Now we have equivalent sets. Equivalent sets are set with an equal number of elements. The sets which have equal number of elements, not exactly the numbers, not exactly the elements. Do not have to have the same exact elements, just the same number of elements. Only the number of elements in the sets will be same, not necessarily be the elements. Take an example. We have a set F which contains 1, 2, 3, 4 and 5. Number of element in set F is 5. And we have a set H which contains HEART. Number of element of set H is also 5. Both the sets have 5 elements. Elements are different, it doesn't matter, but the number of elements are same. So we will say set F and set H are equivalent sets. Only the number of elements should be same. It doesn't matter whether the number are same or not, only the number of element will be same. One more example, set E which contains 3 emojis and set F which contains 3 numbers. Elements are entirely different, but the number of elements are same. Set E has 3 elements, set F has 4 elements. So we will say set E and set F are equivalent sets. Clear? Moving forward. Exercise 1.1. Which of the following sets are the null set? You have to identify whether the set is a null set or not a null set. Null set means empty set. There shouldn't be an element in the set. First one, X such that X is a letter before A in English alphabet. Now we are making a set of English alphabets which comes before A. Do we have such an element? No. So set A will be a null set. Second, X such that X plus 5 is equals 0. X such that X plus 5 is equals 5. It means the set will have those numbers when added with 5. Answer will be 5. Let us consider the number. If we take 0 here, if we take 0 as X, 0 plus 5 is equals 5. Yes, we have a number. We have a number 0 which when added with 5 will get 5 as the answer. So set B will have 0 in it. It means set B is not a null set. We have found out a number that is 0. It means set B will have one element. So set B will not be a null set. Third one, X such that X is a number less than 7 and greater than 8. Now we are making a set of numbers which are less than 7 and greater than 8. Do we have such numbers which are less than 7 and greater than 8 at a time? We cannot have such numbers which are less than 7 and greater than 8. So set C will be a null set. Next one, X such that X is a past president of Pakistan who was a woman. Do we have a woman in the history who was the president of Pakistan? No, we do not. We have a prime minister, but we do not have a president of Pakistan who was a woman. So the set D will be a null set. Next, we have question number 3 from your book, exercise 1.1. Which of these sets are finite and which of these are infinite? The first one, the month of a year. How many months are there in a year? We have 12 months. So the set will be a finite set. Next one, the days in a year. Do we have finite or infinite days in a year? We have finite days. Now we have 365 days. So the set will be finite set. Next, the student of your class. There are limited student in our class. There are finite student in our class. It may be 15, it may be 20, but there will be a finite quantity. So the set will be finite set. Set D, 2, 4, 6, 8, 10, and so on. These three dots shows that the numbers are not ended here. They keeps on going. It means the set will be an infinite set because there are infinite many elements in the set. Part E, the set of lines passing through a point. The set of lines passing through a point. We have a point and we are taking the lines which can be passed through this point. We can take this line, we may 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 take this line. We can take infinite many lines which can be passed through one single point. It means the set of lines passing through a point will be an infinite set. Next, we have the set of lines passing through two given points. Now we have 2 points, first and second, and we are taking the sets which can pass through these 2 points. Let us draw the lines. Only one single line can be drawn that can be passed through these 2 points. It means we will have just one single line in our set, so our set will be a finite set. Moving forward, we have question number 12. Which of the following are equivalent sets? Let us revise equivalent sets. Equivalent sets are the sets which have this equal number of elements. Not necessarily be the elements, only the number of elements will be same. Elements same nahi honge, only the number of elements will be same. Part 1. Set A, ABC. Set B, 1, 2, 3. The number of element in set A is 3 and the number of element in set B is 3. It means both the sets have same number of element. Set A has 3 elements, set B has 3 elements. It means set A is an equivalent set of set B. Check the solution. Number of element in set A is 3. Number of element in set B is 3. Both the sets have 3 elements in it. So set A is equivalent to set B. We use this symbol to represent equivalent sets. Next, set A 1, 2, 3, 4 and set B A, B, C. Here the number of element in set A is 4. We have 4 elements in first set, and number of element in set B is 3. We have 3 elements in set B. Here the number of elements is not same. We have 4 elements in set A and we have 3 elements in set B. So set A is not an equivalent set of set B. We will write it as this: A not equivalent to B. We use this symbol to represent not equivalent sets. Then we have part C. x such that x is a positive integer less than 6. Positive integers less than 6, it means we will have 1, 2, 3, 4, 5 and 6. Okay, set A will have 1, 2, 3, 4 and 5, and set B will have A, E, I, O, U. Now here set number of element in set A is 5 and number of element in set B is also 5. Both the sets have 5 elements in it. So set A is an equivalent set of set B. And that's it. That's it for today, students, and we will continue remaining topics in the next class. Thank you so much.